Okay, there we go. Alright. The last part kind of got cut off a little bit. So I'm going to start this again, and hopefully this works this time. Alright, what I want to know is the total length from segment A to C. So if I took out this B right here, I want to know how long that is. Now I give you B, and I tell you that A to B is equal to B to C. So the segments AB and BC are equal in length. Whatever length that may be, they are the same in length. And I want you to find the total. So I give you AB is equal to 15x plus 5, so I'm going to set the two equations equal to each other, because whatever they may be, they are the same, because I told you they're the same. So I've got 15x plus 5 is equal to 6x plus 32. I'm going to subtract 6x from both sides. These cancel out. 15 minus 6 is 9x, plus 5 is equal to 32. I'll subtract 5x, or 5, I'm sorry, from both sides. So those cancel. Now I have 9x is equal to 27. I'll divide by 9. X is equal to 3. Okay, so I'm going to put that up here. X is equal to 3. And then I'll erase the rest of this. So now I'm going to plug the x back into each equation individually. 15 times 3 plus 5 is equal to 50. And I'll have 6 times 3 plus 32 is equal to 50. So now I know that AB is equal to 50 and BC is equal to 50. Now I just need to add up both sides. So I'm going to have, erase this. So now I'll have AB segment plus BC segment is equal to AC segment. 50 plus 50 is equal to 100. The value of AC segment is equal to 100. So whether that be inches or feet or meters, however you want to see it, it's still equal to 100. Alright. Next page. I wanted to know how many degrees a supplementary set of angles is equal to. Supplementary meaning 180. So I have my straight line, my center point, and no matter how I draw it, total, it's equal to 180. And these are two adjacent angles. Remember from the videos before and from class time, an adjacent angle has a line touching. So it has this ray that's dividing it, not equally, but just dividing it somewhere along the way. And because of this, and this straight line, we know that it's equal to 180. So this is 180 degrees. So the answer for number 17, the supplementary angles are equal to 180 degrees. Okay? Alright, so next up we're going to do complementary angles. That means that total, no matter which way it is, complementary angles are going to have that same shared line again. They're going to be adjacent angles, but they're going to total up to equal only 90 degrees. So see, we don't have that straight line out anymore. We just have our right angle. So these are going to equal 90 degrees. And that's 18. Next up is the transversals. Woo-hoo. I'll have my two parallel lines. Now I'm telling you to do two parallel lines, and on the quiz I told you there are two parallel lines, but remember a little identifier is if you see something like this, at anywhere along the lines, it could be anywhere you wanted, just two little mini arrows within the lines are letting you know that these two are parallel to each other. So then I have my transversal, cutting it, not equally, but at some point. And I ask you to let me know which two angles, the first question, number 20, which two angles are equal to 180, and that would be anything along a straight line. So here, here, anywhere along a straight line. All right. Next, I wanted you to tell me which ones are alternating interior angles. And I labeled them 1, 2, 3, 4, 5, 6, 7, 8. So alternating interior angles, remember, are angles inside the parallel lines, and they're on opposite sides of the transversal. So here's our transversal line. We've all got this down pretty well. Alternating would be 4 and 5, or 3 and 6. Alternating on opposite sides of the transversal. Alternating exterior angles are going to be outside. Remember, exterior, outside. So they're going to be out here somewhere. And they're also going to be on opposite sides of the transversal. So 2 and 7, or 1 and 8. Next, I wanted to see corresponding angles. Again, any particular ones, nothing specific, just a set of corresponding angles. So 1 and 5 would be corresponding angles. Corresponding angles are on the same side of the transversal line, and they're on, one is on the outside and one is on the inside of the parallel lines. So it could have been 2 and 7, or I'm sorry, 2 and 6, or 4 and 8, 3 and 7. So when you're looking at your paper, just as I'm telling you this, just write down to the side. These are all of the options that it could have been. Okay, so next we have supplementary angles. So again, that's just anywhere where they equal total 180 degrees and they have that adjacent line. So it could have been 5 and 6, it could have been 5 and 7, could have been 7 and 8. Any way that they are across a straight line and share an adjacent line, then they are supplementary angles. They're equal 180. Vertical angles are directly across from each other. Remember, that really doesn't depend on both sets, it just depends on one. It's where two lines are crossing each other. Those two lines crossing each other, remember, is called an intersection. So the intersection point, so like right here. So if we looked at just this section, 5 and 8 would be vertical angles, and 6 and 7 would be our vertical angles. They're directly across from each other, they have the same measure. Alright, last page, almost done. So we're going to set up the little mini coordinate plane. Remember, I have my little ticks. And I gave you the point of 2, 1. So you go over 2 and up 1. I wanted you to name this as a whole. As a whole, it's called a coordinate plane. Remember, it's a flat surface. So just like the board itself, it's a flat surface, but I'm going up and down. So I'm actually finding a place left and right and up and down on the y-axis and the x-axis. So, and then this point specifically, this point I wanted you to tell me is called a coordinate. It has an x and a y value. So x, comma, y is a coordinate. Coordinate plane and a coordinate. These are the names that I wanted specifically for these things. Some people said stuff about graphing. Technically, yes, it is graphing, but what I was looking for you to tell me was that this thing right here as a whole, with all these little hash marks on it, is called a coordinate plane. Okay, so next we just have to work through our midpoint, distance, and slope problems, and then we have one last question, and we're almost done. Okay, so number 27, I gave you the same points for all three questions. I didn't want to change the points up on you. I just wanted to know that you recognize that that name went with that formula and that you could plug the points into that formula if I asked you to. So I gave you the points -3, 6 and 2, 1. And I said for number 27 to find the midpoint. So remember, the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2, Now I'm finding the midpoint, so think middle dividing in half, so I'm dividing by 2. Total points divided by 2. I'm finding that middle point. So all I have to do is plug it in. I decide which one is the first point and which one is the second point. So I'm deciding that this is x1 and y1. Now, a lot of you are trying to make this x1 and x2. It is always, always, always going to be x and y. So if I tell you this is point 1 and this is point 2, this is going to be x1, y1, and this is going to be x2, y2. So I'm going to plug my coordinates into the problem. x1 is -3, and I'll put that in parentheses by itself just so I can recognize that it's a negative, plus x2 is 2, the total divided by 2, comma, y1 is 6, plus y2, which is 1, divided by 2. -3 plus 2 is -1, divided by 2. 6 plus 1 is 7, divided by 2. And I told you could leave it like this. You could also place it in decimal form if you like, as long as the final answer is correct. This, if I tried to graph this, would be the correct answer. I could find 7 over 2 and -1/2. And again, this is x, comma, y. So see how the x's just went straight down? It's almost like you're doing two separate problems in one. Next up is our distance formula. And I'm going to take the square root of x2 minus x1 squared, quantity squared, and y2 minus y1 quantity squared. Now remember that quantity, a lot of people are trying to just square the second number. The quantity is the entire thing inside the parentheses. So even if this square wasn't here, I'm taking the second x minus the first x. So I'm going to take my second x, which is 2, minus my first x, which is -3. Now see my second set of parentheses? My second set of parentheses right here is letting me know that the entire quantity, this whole thing is being squared, plus y2, which is 1, minus y2, which is 1 minus y2, which is 6, entire quantity squared. Now next thing, this square root stays there. It stays there until we use it. So I have to draw that back in. Okay, this does not go away until we actually use it. So I'm going to take 2 minus the -3, which is 5. So it's 5 squared because a negative times a negative is a positive. Plus 1 minus 6 is -5 quantity squared. I'm right in front of you again. So now I take the square root of, I take 5 squared is 25. -5 squared is 25 because a negative times a negative is a positive. Now I can't just take 5 or 25 out of this. I do still have to add them together, which gives me the square root of 50. Now I'd like you to factor this if possible. So I'm going to come over here and do a little factor tree. Take 5 times 10, and then 5 times 2. Remember, when I'm taking the square root out, I actually have this little invisible 2 right here. That's letting me know that if I have 2 of something in my factor tree, I can pull it out. Well, I have 2 5s here, right? So I can pull out a 5, and I have 1 2 left. I only have 1, so it has to stay under the square root sign. So 5 square root of 2 is the distance from point 1 to point 2. Alright, next up is our slope, which is rise over run, which is y2 minus y1 over x2 minus x1, which is 1 minus 6 over 2 minus a -3, gives me -5 over 5, gives me -1. So you could have written that as -5 over 5 or -1. Thanks, guys. Bye.